Okay, so this is a continuation of our bracketing method, and here we're going to do our actual example. So please, before you can do this example, make sure that you check the video where we prove the false position formula. So it says perform 2 iterations of the false position method on the function f of x is given by x squared minus 1 using 0 and 3 as your initial interval. Compare your answers to those of bisection method. Okay, so here we're going to compare our answers to those of bisection method. So we proved that when you want to find, let's recall the one of bisection. For bisection, each and every time we're reducing the interval by half, and check if the new C lie between A and C, or the root lie between C and B, whether the new lie between A and C or C and B. So we're going to do the same for the false position, but this time the way we calculate C method. So here we derived our formula that we're going to see as AF of B minus BF of A divided by B minus A. Alright, so this is easier if you can check it. And the reason we're using this method is because it's faster compared to the bisection method, if you can check it. And the reason we're using this method is because it's faster compared to the bisection method. But it's easier also, but slow. So we're trying to use the faster method, which is this one. Alright, so here A as 0 because you're given from this interval here, and your B as 3 you're given from this interval here, and your f of A will be, you put 0 on here in this function, and you will get f of A is going to be 1, and f of B is going to be, you put 8 here, what is this, 3 here, and then you're going to get 8. Okay, so you have your 8 here and this minus 1. Alright, so these are your f of A and f of B. So you say C1 then is A is 0, f of B is 8, minus B is, what's B? B is here is 3, and f of A is minus 1. You divide this by B, which is 3, minus A, which is 0, and you get C1 as this is going to be when you take this, it's going to be, and this is going to give you, this is going to be 3 over 3, which is 1. Alright, so your C is 1 now, C1. So now you have to find a new interval. So to find the new interval, we're using the same procedure of taking the f of A and multiplying it by f of C1. So f of A is already, f of A is this one, is 0. F of A is 0, and then f of C1 is going to be, let me see, we have 1 here, so 1 plus 1 is going to be 0. So it's not less than or greater than 0, it's equal to 0. So let's use another one. Let's use f of B times f of C1 and C. So for this one here gives us zeros. Let's just leave that and try this one. So f of B, it's here, it's positive, f of B is positive, and f of C is going to be this, and that is going to be 0. So it gives you 0 also. So that means if it gives you 0, C is at the center. C is at the center of the interval. So the actually C, the C that you got is the root, not the interval, is the root, because when you multiply both of them you get 0. So here we can perform the next iteration because it already giving us 0. So therefore we say that the interval, the root, you can perform 2 iterations here because the root, and even if we use the actual method of equating this to 0 is equal to x squared minus 1, the root lies in this on what is the 1, because this is going to be when you take to the other side, it's going to be plus 1. So therefore x is equal to plus or minus 1. All right, so 1 is a root and 1 is what we got. So therefore you can proceed further because we already found the root. So do you see how easy and fast is false position method compared to the bisection method? You found the root by one iteration only. You see.